Hello.
Morning.
Are you expecting others?
We'll see. I mean,
Did you send out emails?
I forgot to. Yeah.
Oh,
So,
yeah, please.
well, yeah. I remembered last night at like past midnight, so I.
Yeah, I just saw a notification about a rolling group meeting.
Yeah. I could send one now, but it's probably too late. Yeah, I think because it's once a month, I kind of have to remind people.
Yeah, for containerizzer, I believe Gilbert will always send email or something.
Mm.
But so let me. Do we have an agenda? Did anyone?
Yeah, I haven't filled it out yet, but I had a few things.
Be right back.
Yeah.
Sorry, I'm in a Starbucks, so quite noisy.
No worries. Did you I wasn't sure if people were gonna remember because I didn't send a reminder. Did you notice because I sent the message in the performance Slack channel, or you just
Oh, yeah, it's just on the Apache Mesos calendar.
okay, so you
And also you've kind of mentioned that you want to get some patches in before the performance.
okay, yeah.
work meetings.
Might wait a minute or two more. Let me project the doc.
All right, yeah.
You guys can see that?
Yep.
Okay. So the first, I think it's recording. Yeah. I guess it's recording.
Yeah, there's a red
Yeah,
dot.
there's a red dot, but I can also press record. So I don't know. Well, we'll see, I guess. Hey, Greg. Quick question for you, Greg. I mean, Apache Mesos. Can you hear me, Greg?
Yeah, I can. Howdy.
Are these automatically recorded, or do I need to?
Oh, actually,
Because there's a red cloud, there's the red dot in a cloud, but I can also press record.
yeah. Well, I don't know. It says recording.
Okay.
I
I'll
don't know
just
if
assume
that's
it is.
because I joined with the Apache Mesos account on accident, or
No, it was doing that before you joined.
okay.
I mean, I joined the same way, Apache Mesos. It always does that for me for some reason.
Yeah.
Okay.
Actually, I'm gonna hop out and hop in with my real name, but go ahead and continue.
All right. So the first thing I wanted to just discuss quickly was I created a dashboard. I guess it's a Scrum board or a Kanban board. I always forget which is which. But this should be visible to everyone. It basically just matches the performance label. So if any ticket has this label, it'll show up in the dashboard. And yeah, it's basically just to keep a backlog of things related to performance that we might want to work on. So if we ever have people who want to contribute time, we can kind of pull from this backlog and point them to things to do. So I'll email out some notes from this meeting, just asking folks, letting people know about this label and the backlog, and encouraging them to use this label if they know of any tickets they want that are related to performance.
What's the name of the label? Sorry, I missed that.
It's just performance.
Okay, cool.
So I think I just have to, this link, let's see here. Okay, so this link gets you here. All right, great. The second thing was that I got a few patches in to do some more copy elimination. So I think in this ticket, there was some copy elimination done across the master's existing handlers. So some of them were already done. The re-registration stuff was done as part of the benchmarks we published for master failover. It looks like G did the update slave message handler. So what I did was I did status updates, launch tasks. There's a receive handler, which isn't really used anymore, but did that anyway. There's the accept call handler path. Did some copy elimination there. There's the decline handler, the status update acknowledgements. The scheduler to executor messages and the executor to scheduler messages. So I tried to pick all the things that are most commonly done. I also have a patch that's outstanding right now for, I believe, reconciliation, maybe? Forgot. Let's see here. Yeah, so there's this patch for reconciliation. Oh, it's got to ship it already. So I get that in as well. This one I had to make some changes so that I could improve V1's performance while leaving V0 to have roughly the same performance.
Right. Maybe just like a casual comment, because I apologize for not doing a thorough research.
Yeah.
But basically, after I saw that the patches landed, I just kind of out of curiosity, I kind of just ran our existing reconciliation task reconciliation benchmark.
Yeah.
V1, I mean the V1 patch is not landed yet, but
yeah.
the V1 benchmark didn't work. So I then
Okay.
ran the V0 benchmark, which didn't show improvements. So
Didn't show improvements for this patch, or
not for this one, just for the V0.
just for like 1.4 versus 1.5, or?
No, basically there was a day that you basically committed like this string of 10 patches or something, right?
Oh,
I
yeah.
basically just compared like before and after the 10
Right.
patches.
Yeah, so those didn't cover the reconciliation code, so they wouldn't have impacted it.
I thought it covered V0.
It covers some of the V0 messages, but not reconciliation until this patch.
Oh, I thought.
But the thing to note about this patch is that it leaves V0 roughly the same.
Oh, that's why. Okay.
Oh, well, I don't know. That's if you applied this patch and ran it. This isn't committed yet.
I didn't do this.
Okay.
So this is just some experience, but I'm sure some benchmark. I hope that it's gonna show that with the reducing copying, then.
Yeah.
Sure.
So I've been trying to, like we did with the master failover patches, when there's like obvious performance improvements, like we're just doing fewer copies. I didn't, ask people to write a benchmark before they committed those, knowing that we would write one and have the data available later. So like for all of these, we can have those benchmarks. We already have one for reconciliations, but it's V0. So we could have a V1 specific benchmark that we can run, and we can see that, in 1.6, there's an improvement after having done all this stuff. So I haven't had time to write the benchmark itself yet. It'll need to be a little bit involved because it kind of has to be per call. But yeah. Anyway, this one is just, there was an unfortunate pattern in V1 where V1 tended to, in this particular call, it would basically copy all the data into it would copy it all into like a common interface. So what I instead tried to do is just have V1 be what the interface uses, and then V0 moves into that. So in V1, we're not doing this extra copying to conform to the interface. For the rest of the calls, the general pattern was that V0 would construct a V1 message and then call V1. But in doing that, it would copy all the V0 data into V1. And so I tried to just move it instead in all the other patches. Anyway, I'll get this one committed. And I think that leaves just a few more to do in this ticket, and we should be able to close it. And that should provide some good improvements for people using V1 at least. V0 as well, but yeah.
So you say we need a per call benchmark. Does that mean that we need a benchmark that have a specific scenario that we can trigger the call, or can it be very dumb, like just send out calls and let it fail or something?
Depends on the call. We probably want to exercise some of the logic of the call. So let's say we're doing a scheduler to executor message. We probably want to be able to find that executor in the master code and actually send the message rather than just like look it up, not find it, and then bail. So it depends on the logic of the call, but we probably want to get to like, a common case of it. Like there's already one, for example, for reconciliation, but I think that one's actually kind of dumb. It just doesn't do anything it just sends a bunch of messages, and it's kind of it has kind of been used as a more general message passing throughput benchmark than being a reconciliation related benchmark. It's like the closest thing we have to just measuring the message passing throughput. Because reconciliation is just going to like look that up. It's just going to do a lookup, not find it, send a message back. So with that benchmark, we can kind of tell like how fast the master can process messages.
I feel like probably we can just have a mock scheduler, mock executor, and then just receive anything and reply an egg or something. Like,
yeah, for the master failover benchmark, we needed to do that because it's just too expensive to spin up.
Yeah.
100,000 or like 50,000 agents in one process.
Mm-hmm.
So Ian had written just a fake agent for the benchmark that would reply, or that would send the registration message. So it's spoofing part of the protocol.
Mm-hmm.
So in some cases we might have to do something like that, but we'll see. There's lots of other stuff we can discuss. Performance-wise, did anyone have any specific things they wanted to discuss? I know that Zitao wanted to talk about the state stuff, the state streaming performance stuff.
Well, nothing that's totally different than. So there's a dashboard for performances in general, and
Yeah.
I was just wondering because I didn't spend too much time like thinking, reasoning about various places that could benefit from cost copy reduction.
Mm-hmm.
But I would kind of just like wonder there must be other places, right?
Yeah, for sure.
Like if people have thought about things and they're added here, and then for me, if I have like some time on the side, I can pick up something just for the sake of as a side project. And one thing I wonder is perhaps because the interface from the allocator to the master is pretty intensive, right? It's like a lot of offers getting sent out and generated, users being generated. Maybe that interface could potentially use some copy reduction, like from the allocator to the master, something like that.
Yeah.
So,
We could definitely look at that. I took a quick look like a few weeks ago, and I didn't see a lot of potential there, but there's also this ticket we filed in the past, which was to have resources be copy on write. That we might want to look into. But yeah, I think that's definitely one great place to look at is the allocator interface.
well, when you said you didn't see a lot of potential, what's the things that you consider when you look into that?
So what you want to see in here is so there's some potential here, for example, like the fact that this passes back, this calls back in with like a framework ID and a map, like a nested map structure of the offers that can probably be moved back to the master. because I think the allocator throws this away. Same thing for this inverse offer stuff, but not a lot of people use that right now. Then you have all the calls that the master makes. So that's calling back to the master. Then you have all the calls the master makes to the allocator. In a lot of cases, like, you know, framework ID, framework info, we're not gonna be able to move that stuff in. It might be possible that we could move some of this stuff in, like this used map, right? Like when we add an agent, this
Right.
used map, like if we're constructing it in a temporary way, we could move that in.
I see.
If we're grabbing it from something that's already available, then we wouldn't be able to move it. We could still make this take an R value, but we wouldn't achieve any win with that.
Right. So I'm mainly referring to the two callbacks because these were like invoked at least once per second with like the entire cluster being in that callback, right?
Yeah. Yeah, definitely. So
these were like, yeah, when agents, frameworks come and go. Well, recovery resources are probably called more often.
Yeah, that's a big one too. So yeah, some of the stuff we should look at, and I haven't looked at it too closely yet, but there's a little bit we could do. I guess it might help a lot in some cases, like maybe improving the callbacks help a lot. We're also going to be changing this stuff to move the offer ownership into the allocator, so that's going to change some of this code as well. But you're mostly concerned about the master, right? Because there's a lot of stuff to do in the agent, but I assume that we haven't really focused on it because it's not really
in terms of component, yes.
Yeah. Okay. I also noticed that there's some potential for copy elimination with protobufs in the replicated log as well, but I didn't write any code for that. But you can basically just look at anything that's doing an install and take an R value with that, and then move the data if you need it copied in the current code.
Got it. So the same way that the install handlers are done in the master actor.
Yeah, most of them at this point. That's kind of what I was doing, was just looking at all the installs, and then I noticed that the replicated log has some as well. And the main thing there was that it could move the binary data. Not sure how much of a win that's going to be, given that I assume it's pretty fast to copy like a big binary string, but that should help a little bit. I mean, these are all pretty easy patches to do, so that's why I just tried to just take care of some of them over the past few weeks when I had time. The allocator stuff might be pretty straightforward as well, so that would be good if someone else wants to look at that. That'd be great. Otherwise, I'll see if I can take a look before the next meeting. What else here? Yeah, we've largely kind of gotten away from having to optimize the allocator performance much at this point because of the batching that we did. And there have been some improvements in the past. So, I mean, I don't know about you guys, but I haven't really been looking at allocator performance in terms of how quickly it can do a cycle of allocation.
Hey, Ben, could you just explain at a high level the batching that was implemented? I'm not familiar with that.
It's the same batching as the registry uses. Like the registrar will take, what it does is while an expensive operation is happening, in the case of the registrar, that's a write to the replicated log. That takes some time. While that's happening, we'll queue up all the incoming operations. And when the write completes, we'll process all those queued up operations in one single step. Like those will map to another single write, subsequent write to the replicated log. So if we had, let's say we got our first operation, we go and do a write. Now while we're doing a write, 1,000 operations came in. We queue those up. Now when that first write finishes, we look at the queue and we're like, okay, great, there's 1,000 things this time. So let's process all of those in memory. Now let's write the difference to the replicated log once for all those 1,000 things applied together in one batch. And so the throughput should be fairly insensitive to the latency of the log writes. Does that make sense?
Yep.
Okay. So in the allocator, the expensive thing that we do is an allocation cycle. And operations that are happening are things like agents getting added, we recovering resources, frameworks getting added. Many of those things trigger one of these expensive operations, which is an allocation cycle. So what we'll do when operation comes in that triggers a cycle is we'll defer that cycle behind all the other events in the queue of the allocator itself, like the actual event queue of the process. So that next time when we finish that cycle and when we process some event afterwards and we want to trigger another allocation cycle, that'll get queued up behind all the other 1,000, add frameworks that have happened in the interim while the last allocation cycle was running. Does that make sense?
Yeah.
Okay.
Thanks.
So it's just a similar principle there of just protecting the expensive thing from being event based on like every single event coming in to based on, a batch of events. And that, I think that was one of the main reasons we had to stop constantly battling with the allocator performance. I'm pretty sure we've made it worse, but we haven't really known, or no one's complained because of the batching behavior, I guess. So, yeah, I think we had I think a while back we collected a bunch of people's ideas somewhere in this talk. I forget. But what my thinking currently is that like, if I were to write down a roadmap or like near-term roadmap, I don't know who just joined. Can you hear us?
Looks like Gilbert.
Oh, Gilbert, okay. I was just wondering if it was a Tao because I know he wanted to talk about something. If I were to write down the near-term roadmap, it would be probably additional copy elimination, finish master, look at allocator, maybe look at replicated log. And then there's two things that I think are going to come up. One is the state streaming into state actor to improve state query performance and to avoid interrupting the master, then state is pulled. And the second thing is just HTTP, let's say libprocess, HTTP performance improvements. There's a variety of things here. One is having a process per request or connection, i.e., you know, it's the best way to explain this. Requests are initially processed using their away, I guess I'll say away from main actors like the master. Handler can dispatch to the master when needed. So does that first thing make sense to folks? The idea is that we want, if you look at other HTTP libraries that have a kind of like a user level threading model like Go, what happens is that every request handler is invoked in a Go routine that gets spun up for that request handler. In a similar way, like one of our performance problems is that the request processing, part of it is done by libprocess, like parsing the message and all that. And the same thing happens in Go, like the server parses the message, but once it's parsed, we hand it off to the handler, and that handler's running and it's blocking the master. So if the master's going to do anything like doesn't need master state, like validate the message or like deserialize part of it or whatever, that's all done on the master, whereas it could be done on an independent actor that's running in parallel with a bunch of other actors. So we want to try to get some of that initial work, and like basically the beginning, the request processing, and the end of the request processing that don't need to happen on the master, we want those to be outside of the master actor.
Do we have reason to believe that that's that we're spending significant time? Like, I guess that blocking is causing performance issues for the master or other actors?
It's certainly only going to be relevant for now for the master, because we just don't run other actors at such a high load as the master. For the master, when we ran benchmarks, a significant cost is in deserialization and validation of messages. Deserialization tends to not need the master related state at all. And validation, much of it is stateless. Some of it's stateful, like it needs to look at the master's data structures to see if this makes sense, but some of it is just, is this thing well formed and all that, and we have to traverse the message and look at things to do that. So those pieces, if we could have the master be deserializing all the incoming messages in parallel across all the messages that are coming in, that would be an improvement.
So you're saying you did some profiling that showed significant time spent in that initial validation?
Well, we measured things like deserialization and so on. If you have like a master failover benchmark where you've got like 50,000 messages to deal with, the total cost of deserializing all those messages is very high. And so if you can do that deserialization in parallel rather than serially on the master, you spend less time in the master just not doing anything other than deserialization, and you can get a little bit of like Amdahl's law and speed up the parallel part of the flood of incoming messages.
What deserialization is the master doing exactly?
It's deserializing protobuf, so it's got a binary string, which is coming in the HTTP body, and it's got to construct a C++ protobuf object from that. In the case of V1, it also has to do some expensive evolving, or devolving rather, from the V1 incoming binary data into a V0 C++ object. So in order to do that, it will go through V1 C++, serialize that again, and then deserialize that as V0 C++.
I feel like,
And that,
sorry, please continue.
no, go ahead.
Well, I feel like instead of having a process or actor per combination or request, probably like doing something like it's called async and call the serialization. Like create actor ad hoc, do things, and then get it after it's done.
Yeah, I mean, the other part of this change is that I think it's probably the model that we should have started with. Like if you look at the routing API in the process, the routes are bound to actors, which was an unfortunate decision, because if you want to change an actor name or like move things, refactor things, and you no longer have a certain actor, your routes are kind of stuck with those names in them. And you have to like fake that there's an actor there. The API is also something that I wanted to just improve. But yeah, I mean, you're right. You could still go through the master serially initially and sequence all of that work. You probably need to do some sequencing there to make sure that it's still ordered correctly and everything. But it just kind of seems to me to be a little more complicated than an approach where like handlers are freestanding and they call into things when they need to go to a specific actor. Like it's a little unfortunate right now that the API is hosted by the master actor.
Yeah.
I would love to have /master/API be able to decide that that's, oh, we want an API actor for that or something, right? So that's my other motivation with this, is just that I think decoupling it would be advantageous for the API of libprocess routing.
Mm-hmm. Yeah, I probably need to take a look at it, like what the new API would look like to try it out.
Yeah, but I like the direction. Yeah.
The other thing is just we need to do some benchmarking. There's likely going to be, this is my guess. Okay, I'll just say like need benchmarking of libprocess HTTP server. Likely needs some copy elimination, potentially, I found a faster parser as well. I don't know if that's going to help a benchmark or not, but might do that. Yeah, I'm kind of forgetting off the top of my head. I haven't looked at that code for a while, but it hasn't really been optimized too much, and we were waiting for Ben H's patches. What I should probably write here is land Ben H's libprocess HTTP server patches. And then we wanted to benchmark that code path to make sure that it's not a performance regression against what we already have. And then we wanted to optimize this library called HTTP server rather than the existing HTTP server in the process, which is kind of spaghettied into the code. So that's kind of what I was thinking on the process side.
One thing that Ilya had mentioned to me recently was that the profiling that he'd done, they noticed a lot of time spent in the authorization step in libprocess.
Right.
So I think that's probably some low-hanging fruit that we could take care of pretty easily.
Well, yeah. So I remember that. I don't know how easy that's going to be, but yeah, that's definitely a big performance problem. Why is it easy?
No, I guess why do you think it might not be?
It's just that code it's sequencing everything and it's doing additional dispatches, and I don't know, that's pretty expensive. So when I looked at it, it's not obvious to me if it's going to be easy to make that faster or not. It's possible that like I'd have to investigate how other libraries are, like maybe in Go, how they do authorization or authentication.
Yeah,
the one thing that I thought would be easy was if we actually had connection-based authentication, which we haven't implemented yet. We only have per request authentication, which is why it's so expensive, right? Every request has to be authenticated.
Well, I think he was talking specifically about authorization, not authentication.
I don't.
We have.
Sure? I don't think libprocess does authorization, does it?
It does, yeah. So there are just a few endpoints that get handled in libprocess. And so you can install callbacks in libprocess to handle authorization for those. What is it, like the metric stuff?
Right.
That's sort of libprocess level.
My battery is running out, so I have to drop off my.
Right.
All right, no worries.
Yeah.
So I think we go through this authorization code for every request, regardless of whether it needs to be authorized or not. And most requests are not authorized at the libprocess level.
So he ran the reconciliation benchmark, if I remember right. He had shown me a V1 version of it, where he said that this additional code here, I don't remember if it was authentication or authorization, was what made it a lot slower, like 2x slower or something like that. So yeah, it would be good to dig in there. I don't know. I don't understand the problem exactly, so I can't really speak to that.
Yeah, it's possible because of the overloaded use of the word authorization. I might not know precisely what he was indicating, but I think that we can probably, I think we can avoid executing some of that code for most requests.
Well,
place to investigate.
Yeah, we certainly have to look into that. I had been pinging him a while back to help just remind him to kind of. I wanted to wrap up that benchmark he had, but he's just been busy with other stuff, I guess. So yeah, that I'll write that down as another area. Yeah, thanks, Craig. That's probably coming sooner than some of this other stuff. If it affects V1 pretty negatively, like he was saying. Yeah, what else? Another thing that I filed a ticket for is just to have a parallel loop construct in the process. Because when I was looking at some of the master code, there were some cases where there's basically a const loop over a lot of things. One example is reconciliation. We're going to do a loop over all the incoming tasks that want to be reconciled. And the logic inside each loop iteration is basically constant against the master. It's just going to look up the task and so on. But the sheer number of tasks in there, like for large schedulers, when it's 100,000 tasks, it's pretty expensive to actually run the loop. And so it would be nice to have something like a parallel loop when we need it, when we have code that fits this pattern, to be able to speed that kind of code up. There's a lot of subtlety to discuss with something like this. And there's also the C++ parallelism TS that is basically introducing a parallel loop, but that TS does not specify how it's implemented because they don't include like a thread scheduler. So what I was thinking for this is that we'd probably start with just adding something to libprocess that uses our processes to achieve this and to make sure it doesn't deadlock and so on. But longer term, I'm not sure, like it might make sense for libprocess to integrate more with the stuff that gets standardized in C++ when it comes to parallelism. So yeah, I don't know if anyone's interested in discussing this, but it's just a ticket I filed to eventually look into this. Is there anything else anyone wants to discuss?
No, I don't think I have anything.
Did you have anything, James?
No, I don't have anything today.
Okay. Okay, well, if that's it, can end a little bit early. Thanks, guys, for joining.
Yeah, thanks, man.
Thanks, Ben.
All right. See ya.
Thanks, man.
Later, y'all.